So guys, what we'll be trying to do in this video is to try and do the connection for our security door. As you already know, we want to try and use security keypad to unlock our door. Presently, our door will be represented with this servo motor right here. This is the keypad. This is our LCD display that will be telling you what to do at every given point. If you enter the wrong password, you will see it displayed here. If you enter the right password, you see it displayed here. Here we have two LEDs. What these two LEDs will be doing is to indicate right and wrong. Once you get the password correctly, this green LED will glow. And once the password has been reset, it will go back to red. So at every given point in time when you meet the door locked, it will be showing you red. So basically, once the right keypad or right security pin is entered on the keypad here, this as soon as this door is opened, it will be green. This green LED will be turned on to indicate that the door was opened, and once it is locked, reset back to default, it will go back to red. So let's just see how we can make the connection. So basically, this is our Arduino Uno. We have digital pins here, and we have the analog pins. So we'll be using the digital pins and the analog pin because the digital pins will not be enough for us to carry out this experiment because we have three different modules here that needs to be connected to this Arduino. As you can see, this is just Arduino Uno. This is not Mega, no. So as it is, we have limited space for digital pins, so we'll be combining analog and digital pins. Here are the analog pins which can also be used as digital pins as long as you reference them well in your code, they will work. So this is our keypad, as this whole tutorial is centered around this keypad. We just want to be able to open our door using the keypad instead of key and all that. So this keypad you see here, as you can see, we have 8 leads going into this keypad. This keypad is wired in a matrix of rows and columns, which I won't be going into right now. So, but basically, this is it as you see on the screen. So, what we'll be doing is try and do the connection. So, for this first 4, where you have this darker color here, I'll just call them A1 to A4, while we'll call this last set of 4 B1 to B4. So, excuse me. Right now, we'll just try and attempt connecting them. So, for the keypad, we'll be using the digital pins. So, we're going to start the first one from digital pin 2. As you can see, I'm on the digital pin 2. So, I'll just click on it. So, the first one has been connected. So, we'll move to 3. Right now, second one has been connected. Move to 4. Good. Move this down a bit. So we have space for this. So take this. So this is the pin 5. So as you can see, our first 4, which is A1 to A4, has been connected to our digital pin 2 to 5. So right now we'll continue the connection. So we'll just locate pin 6. There you go. We'll go for pin 7. There you go. Go for pin 8. Don't mind the connection going into each other. The fact is that they are not linked to each other. There's no bridge between them because these cables are insulated. So we have one more to go. So we are using up to digital pin 9 in this very connection. So I just link the last one. There you go. We have our keypad fully connected at this point. So let's wire our display. This is an I2C display which uses just 4 pins to connect to this screen. This is a 16 by 2. Usually you have a lot of pins connected to this display, but with the I2C, you just have 4 pins. You have the ground, the VCC, the SDA, and the SCL. So the SDA carries the signal, the SCL is the clock that clock the screen. So to activate it. So right now, we're just going to do the connection for that. So we'll be using pin A4 and A5 for this screen, while the other two is ground and VCC. So we just wire it right now. So let's do the connection. Basically, SCL, which is the clock, will be going into pin 5 of the analog. So connected. So pin 4, which is meant to go into SDA, as you can see on the screen, it has been terminated. So VCC is a plus 5 volts. So take plus 5 volts VCC. So we'll take ground, which is our negative. There you go. So we've successfully connected this screen. So what we have left right now is our servo motor and our LEDs. So basically, for this servo motor, we have the ground, the VCC, and the in. So this is the ground, this is the VCC, and this is the clock in. So right now, we're going to connect VCC. So that has been terminated. So we'll take ground from here. So that will be terminated to ground. So this is the clock in. So you can see this is servo PWM. This is where the servo motor receives the signal to move at angles. It can either move 360, 180, or angle 45, angle 90, depending on the rotation you're going for. So right now, the clock of this servo motor will be connected to our pin 10. So we'll take 10 of the digital pins, then connect it. So our servo motor has been completely connected at this point. So what we have left right now is these two, our LEDs to trigger when the system is opened and when the system is fully locked. So right now, the LEDs for the signal, this is the LED signals, as you can see here. This is the positive, here is the negative. Positive, negative, positive, negative. So right now, for the green, we're going to be using 12 and 13. So for green, we'll be using 13 for the green. So we'll connect this to pin 13. Then for red, we take pin 12. So that has been done. So for pin 11, we're not making use of that right now. So let's just move. We'll take ground. We give so take ground again. So there you go. System has been fully wired up. As you can see, all things being equal, should be able to work well. So right now we need a sketch to drive this system. So I've just dumped a sketch right now on this. So I'll try as much as possible to explain the sketch. So basically, this first tool here, as you can see, these are the three libraries that we need to drive this system. You can see we see servo.h, keypad.h, liquid crystal I2C.h. Now for the liquid crystal you see here, this is the screen. For the keypad, as you already know, keypad, then the servo.h is the one, this is the library that controls this servo motor here. So we need all this. As you can see, I already did the commenting. So each of the lines you see comment attached to it. So for this servo H, this servo S1 is just the line of code that initializes this servo motor to work as soon as this keypad is entered correctly. So the liquid crystal, this is the liquid crystal that initializes this screen. This line of code here tells the screen what kind of screen to initialize. As you can see here, we have the LCD 0x2716,2. What this means is this X 0x27 is the address line of this screen. Some in my other videos, I already made a video on how you can check for the address of this screen, because a module has been connected behind it, which is the I2C module. So you need to be able to know the address of the I2C module in order for you to address this screen, for it to work well. So for this screen, I've already checked. This is the addressing line for it. Then this 16 tells the kind of screen we are using. 16,2. This is a 16 by 2. We have 16 rows here, 2 columns. So there is a complete 7 segments, 16 of them arranged on this row in this screen, while we have 2 segments arranged in columns to meet with the 16 we have on the horizontal and the vertical. So what we basically mean is for the horizontal we have 16, for the vertical we have 2. That is why you're seeing this here. So this is basically the line of code that initializes this screen. If not, the system will come on, this screen will not turn on. It will just be on, but it won't display anything. So this is the line of code that initializes this. So basically, these are just constant to initialize, to actually tell the system the pins that have been addressed for each of these system to work. So basically, if you need to change the password and all that, password size and all that, this is what you need to do. This is the password size length. Right now we are using 4 because this is a 4 by 4 keypad. So we are using just 4 for our password. So if you need to change it, this is where you change the digit. So for the password size, an actual pin size, we'll be using just 4. Now, if you look at this keypad here, we have 1 to 9 or 0 to 9. We have star, we have hash, we have ABCD, which means our password can be alphanumeric. You can combine both numbers and alphabet for your password, and it will work perfectly. So basically, the third line of code here is the character password size, which I already declare here. So our password in this step right now is going to be 1 to AB. This will be the password that we initialize this system to work. So basically, that is just what this line of code means. So once it has been entered correctly, system will work and this servo motor will move to tell you the door has been opened. So basically, what we have here in this line of code here is just telling the system Arduino that this is a keypad of 4 by 4. So this is the keypad that has been arranged here in codes. In other words, when you're pressing, the system detects which button is being pressed by because of this line of codes that are already placed here. So basically, every line of code here has already been commented out. So just try and go through it. In order to make this video too long, go through it and understand what each of them means. Try your connection, upload this code, which you'll be seeing in the description, or a link will be provided for you in the description of this video, whereby you go and copy this full sketch, upload it to your Arduino Uno. You can also use Nano if you wish to, but in this case, Uno is more preferable because of the fact that we are using 3 different modules combined together in this tutorial. So basically, this is it. So right now, I'm just going to try and simulate this system and let's see if it works. So what the system is saying that I didn't install Servo on it. So right now I've already installed the library Servo Keypad and I2C. So let's try and initialize it one more time. Welcome. As you can see, the system works right now. So it's saying enter pin. So right now, let's just see. As you already know, I already specified the pin here, 1 to AB. So let's just try 1, 2, 4, 5. As you can see, the system says wrong pin. So right now, let's try the correct one, AB. You see the servo motor has moved and it's saying that the door has been unlocked. So let me move this servo motor a bit up. Let me stop this first. Move this. Let me move this a bit up. Okay. This serial monitor here is kind of, I think, better ways to reduce my screen. Yeah. So using my screen size right now gives us a better view of what we're doing. So here we go. Now let's run the simulation again. So you can see Arduino is on here. You see this servo motor right here. I'm going to stop it again. So I'll move it back down to avoid obstruction. There you go. So let's start the simulation all over. So you can see, say welcome. Our screen has been initialized. Say door is locked. Enter pin. So right now, let's just try say wrong pin. So let's try the right pin. I think I didn't get it right. So let's try it now. One, one, two, A, B. There you go. It says door has been unlocked. Enter hash to what? Lock door. So if you press hash, the door goes back to lock. So right now, I don't really know why LEDs are not glowing, but it's up to glow. I think I'm just gonna check that out maybe later on this video, but right now what we're seeing on our screen shows that our code is working and our system is working perfectly. So this servo motor here represents the door lock, of which in our next video I'll be upgrading this keypad lock using a solenoid lock that will need to connect a real door lock to this. And once the keys has been pressed, the door will lock and unlock. So we eradicate this servo motor and put a real solenoid lock. So right now I'm even going to see if I'm going to be able to see that solenoid lock. As this part, I think it's not here. Door lock. I'm going to check the entire library for that solenoid lock if I'm going to be able to see it. But right now, I'm not saying it. Maybe I'm not searching the right name. So, but however, I'm just going to see, just close this out. For this, I'll be showing you the physical illustration on the one the system I've wired up like this. This is just a simulation. I'll be showing you this in the system I already wired up using every component here. So right now, the basic need for this tutorial is just to show you how you can do the connection yourself. So I already did the connection, uploaded the code, and it's working perfectly well. So right now, we're just going to merge both side by side and show you how it works. While this is running, I'm going to be showing you how the physical device that has already been designed works. So basically, I'm going to be adding a little upgrade to that probably, but I don't know yet. I might just add RFID tag to this system in such a way that we can be able to use smart cards to open this same door instead of keypads. The keypad will work, the smart card will work. I might do them on a separate video because of the fact that this Uno has limited digital pins and analog pins to carry those extra modules that will be added. But however, I think it's applicable to also run on this same because we still have some space left which can also be used for that. But because RFID has a lot of pins as well, I might be doing the RFID door lock control separately on a separate video in order to make the video probably a bit shorter, because if I'm going to be doing that here, it's going to make the video too long. So this is the basic connection you need for this system to work. So for a student who is in the electronic department, for instance, engineering, can pick up this project, implement it, and use it for a diploma program as a project defense. So, however, try this out. Drop a comment for me if it works for you or not. If it doesn't work, I'll walk you through how you can debug yours to make it work. Probably walk you through the connection, then we'll see how we'll take it up from there. But right now, this is basically what we need to get this system working. Thanks for watching. I'll see you in the other video. If you love what you see, please like, subscribe, and share this video to your friends in order to encourage me to do more. Thanks.